Now, what are the Boolean? What do we use in conditionals? We use Boolean expressions. What is a Boolean expression? Boolean expression is an expression which produces at the end either a true value or a false value. Well, how can we achieve this? We can do it by comparing values. We can compare values with equal to operator, not equal to operator, less than or equal to, greater than and greater than or equal to. These are equality and relational operators. Using these relational operators, we can compare two quantities, two data, and get as a result either true or false. We can also use logical operators, not operator, and operator, and or operator. Be careful in Java. In order to use the AND operator, we don't use the word AND, we use double AND sign. And for OR operator, we use double vertical sign. Okay, we don't use the word OR. We must use this double vertical sign for OR operator. From high school, probably you know the truth table for AND and OR operators. Assume that A is a Boolean expression, which is either true or false, and B is a Boolean expression, which is either true or false. When we use the AND operator between Boolean value A and Boolean value B, what is the truth table for this? If we have AND operator, in order to have the result true, both A and B must be true. If any one is false, A and B produces false. When we use OR operator, if any of the arguments are true, then the result is true. If both are false, then the result is false. We know this from probably high school. So let's see here a few things. Assume that I have these variables A equal 12, B equal 4, C equal 3. If I compare A with B multiplied by C, what is B? 4 multiplied by C, 3, 4 times 3. This is 12. This is 12. When I compare them for equality, the result will be true because this is 12, this is 12, and B multiplied by C is 12. Therefore, A equal B asterisk C as a Boolean expression will be true. For example, let's look here. A is 12. B plus C is 4 plus 3, 7. 12 greater than 7 is true. Therefore, this parenthesis is true. But in front, we have not operator. Not operator reverses the Boolean value. If we have here true, not true becomes false. If we have here false, for example, B plus 8 times C, C is 3, 8 times C, 24 plus 4, 28. 12 greater than 28 is false. Now we have here a false value inside parentheses, and not false makes it true. Okay, this the whole expression will become true. So by using relational operators like equal, greater than, less than, etc., we get a Boolean value. And by using and or operators and not operators, we still continue to get Boolean values, true or false values. Let's do something which contains and. That we can have, for example, something like this. A less than or equal B, and let's put here an or, two vertical sign, and then let's put something else here. 2 multiplied by C, 2 times C greater than B, for example. When we have such an expression, there are certain rules to compute the result of this expression. Some operators here, for example, we have multiplication operator, less than or equal to operator, greater than operator, and or operator. There are 4 operators, 1, 2, 3, and 4. They have some precedences. Inside this Boolean expression, the operator that has the highest precedence is multiplication. For this, we have an precedence of operators table. Okay. We can also have some assignment operators, etc. Assignment operators have the lowest precedence. The highest precedence belongs to the index operator, parentheses, and the dot membership operator. We will see this in more details later on. Here, for example, I can put a parenthesis, okay? Therefore, the parenthesis has higher priority. Therefore, when I want to evaluate this, since the parenthesis has priority, this will be done first, okay? The multiplication will be done first. Even if I don't put parentheses, since among these 4 operators, this and that one, multiplication has higher precedence. There are the precedence goes like this. The highest precedence belongs to index operator, parentheses, and the dot membership operator. And then we have plus plus and minus minus operators, increment and decrement operators. Logical NOT is here. And unary plus and unary minus. What is unary minus and unary plus? Assume, let's write here something like, for example, n is equal to x multiplied by minus 5. Okay. Here, this minus is not subtraction operator. This minus is a unary minus operator. Okay. Or it can be, instead of minus 5, I can make it, for example, minus y. Okay. Here, this is multiplication operator. This is unary minus operator, which makes just the value of, it takes the reverse of the value of y. If it is plus 5, it takes minus 5. It is minus 7, it takes plus 7. Okay. So if we have in a expression unary plus and unary minus, its precedence is before multiplication. Here we have multiplication operator, we have unary minus. What happens? So first unary minus is performed. We negate the value of y, and then we multiply that by x. Okay. So here this unary minus has higher precedence than this one. Let's put here another minus, minus z. This minus y is unary minus. This minus is the subtraction operator. Okay. Here we have, let's put this like this, or z minus. Let's put it like this. Okay. So there are 2 minuses. This is unary minus, which has high precedence. Here it is unary minus, and subtraction operator has precedence level 4. Therefore, this is done first. The multiplication has precedence 3. Multiplication, division, and modulus, or remainder operator, comes after the unary plus, unary minus, increment, decrement operators, and logical NOT operator. After multiplication, division, and modulus operators, addition, subtraction, and string concatenation operators comes. So here, this has the higher precedence. So when I write below those, their order, this is done first. The multiplication is done second, and the subtraction is done third. Okay, this is the order of performing the operators. And then after the addition, subtraction, and string concatenation, the relational operators comes. After relational operators, we have equality operators. So these 2, equal to and not equal to, has lower precedence than the other 4. Okay? The other 4 has a slightly higher precedence at level 5, and at level 6 we have equality operators, these 2 operators. And then after this we have logical AND and logical OR. So here we have, for example, logical OR. We have greater than, less than. Let's put here, for example, equal, or not equal, or equal. That's okay. So here we have 4 operators: equal to operator, or operator, multiplication operator, and greater than operator. Which has higher precedence? Multiplication has higher precedence. So this is done first. What is done next? We have these 3. Among these 3, greater than operator comes next. Greater than is at level 5. Okay. At level 6, we have equal, not equal operators. Equal to or not equal to operators. So this asterisk is done first, and then after that, this C greater than B will be done. So 2 times C will be computed. We will find the value from here after the first step, and then this value is compared with B. If this will be either true or false. Okay, comparison of 2 times C greater than B will be either true or false. And then what is next? OR operator has quite low precedence. So here this will be done next. 3. Oops, sorry. And this will be done at the 4th stage. So when we look to this expression, these values 1, 2, 3, 4 are just the order of operation execution. First multiplication will be executed, then greater than will be executed, then equal to is executed, then OR is executed. So a value is found here at the first step. This is compared with B. This is either true or false. 2 times C greater than B is either true or false. And then A equal to B is executed. This is either true or false. So we have a true or false here, another true or false here, and then with OR operator, we just combine, we check for the logical OR case of these 2 Boolean values. Okay. So you have to know this precedence of operators table. Okay. It is not too difficult. Unary plus, unary minus, increment, decrement is first. Of course, before those parentheses has higher priority. Then we have unary plus, unary minus, increment, decrement. Multiplication, division, and modulus has precedence over addition and subtraction. You have to know that. And then after the mathematical operators, the relational operators comes first, greater than the relational operators, and then followed by the equality operators, and then logical AND and logical OR. If we have an expression which contains both logical AND and logical OR, first logical AND is performed, and then logical OR is performed. Let's do an example. For example, A greater than B, greater than B. Let's put here an OR operator. C equal D. Assume that we have also D, etc. Comma D equal to, and then let's have here an AND operator, and A plus B less or equal to C multiplied by D, for example. Okay. So here we have a longer expression. Let's write below this the order of operators. Here we have multiplication, which has the higher priority. So C multiplied by D will be computed first. And then we have addition operator. A plus B will be computed. We have a value here. Then we have greater than, equal, less than or equal, OR and AND operators. Since OR operator has the lowest priority, this will be done at the end. Just before that, this will be done. Among these relational and equality operators, greater than, less than, blah, blah, let's write below this is done first. The multiplication is done first. Okay. And then here we will have this done at the second stage. Now we have greater than, equal, less than or equal. As we have seen from this table, equality has less priority compared to relational operators. So this will be done at the third step. This will be done at the fourth step. And then this will be done at the fifth step. Now we have only left with or and. We have from A greater than B. After the third step, we have a true or false value. After the fifth step, from C equal to D, we have either true or false. And from here, after the fourth operation, less than or comparing this A plus B with C multiplied by D with less than or equal to, we have a true or false for that part. So true or false, or true or false, or true or false. Some values here. Which one will be done first? Between AND operator and OR operator, this will be done first. So let's put here 6 and here 7. Okay, this will be the order of execution. First perform the multiplication, then perform the addition, and then perform the greater than, and then this two, greater than and less than or equal, has equal precedence. When they have equal precedence, they are processed from left to right. I forgot to put this. We do first the leftmost one, and then we go to the right. Okay. I don't need this because they are not put together. If I have, for example, something like A plus B minus C plus D, here I have addition, subtraction, addition. They are all in one expression, and we process them from left to right. This is first one that is this is computed. Then we do the subtraction and we do the addition. But we cannot write something like this: A greater than B, less than C, blah blah. This is not possible. Okay, we cannot write something like this. We cannot combine two or more relational operators or equality operators together. We have to have some, because this result is a true or false, and then with this true or false, can we compare a value, for example, a number? No. So we cannot write something like this. That's why we didn't put here left to right. They cannot be combined, but plus, minus, or multiplication, division can be together. I can have A divided by B multiplied by C modulus D, for example. We have all these three: division, multiplication, and modulus has same priority level. They are all at this level, okay? But if they are together in one expression, they are processed from left to right. So first, the division will be done. A will be divided by B. A result will be found, and then it will be multiplied by C. A result will be found, and then modulus D will be performed. Okay? But the same case doesn't apply to greater than or similar things. We cannot do this. Okay, we cannot do something like that. It's not allowed in Java. If you want to do something like this, you have to do A and B, A greater than B, and then and B greater than C, and then and C greater than D. Okay, you can do this. A has to be greater than B, and B has to be greater than C, and C has to be greater than D, and then this is equivalent to the other one: A greater than B, greater than C, greater than D. But I must write it like this in Java. In some other languages, you can write the other way around, but not in Java. So we have to memorize this. After a while, you just get used to it. Multiplication, division, modulus has higher priority than addition and subtraction. This is the most frequent things that you have to know. Whenever you are in doubt, just use parentheses, okay? And logical OR is just has the lowest priority except the assignment operators. Why assignment operators come last? Here I can have, for example, n is equal to this, okay? Oh, sorry. Let's put again here, multiply divided by b multiplied by or modulus c plus d multiplied by e, for example. These operators are performed, a value is found, and then at the end, assignment is performed. That's why the assignment operators has lowest priority. Strangely, we can have n is equal to m is equal to q is equal to, for example, a multiplied by b. We can have this. We can have multiple equal or assignment operators together. What happens? Here, multiplication has higher priority. Therefore, a multiplied by b will be done first. And then, as you see, it goes from right to left. So the value found by multiplying a and b will be assigned to q. This will be done after multiplication. Multiplication is first. This equal is second. So q will be assigned this value. And the same value is assigned to m. And then the same value is assigned to n. That's why here we have right to left. RL means right to left. It goes from right to left, okay, in the reverse direction. This value is assigned to Q first, and the same value is assigned to M, then assigned to N, etc. So this is the precedence of operators table. We can continue with if statement. Let's remove all of these. What's an if statement? If statement contains a logical expression. If, and between parentheses here, we have a Boolean expression or logical expression. For example, A greater than B. This result is a true or false, as a Boolean value, true or false. And then after if, we will have a block of statements. And here we can have something, okay, whatever, okay, a Java statement. Java statements can be put between curly braces. When we have a send statement in Java, we finish with semicolon. But if we have an if statement, we should not put semicolon. If I put semicolon, it is useless, okay? It doesn't serve anything. So don't put semicolon after B, because if statement is followed by a block of statements which is put between curly braces, and if statement is finished here. You can put here a semicolon, but normally you don't need to put, putting a semicolon here doesn't help at all, okay? This is how an if statement is written. Between if, after if, we have a logical expression or Boolean expression. And if the Boolean expression is true, then those if statements are executed and continue with the next statement here, whatever it is. Here there are some statements probably. If the Boolean expression is false, it does not execute this. It directly jumps to the next statement. Just same as the if statement in Python. But the difference is, first difference, we must put parentheses. Parentheses is must. Okay, you must put parentheses. And if there's only one statement, you can do something like this. Let's copy this. If there's only one statement, like for example, n is equal to 7. Let's put a statement here. If there's a single statement, you don't need to put curly braces. But if there are multiple statements, like, for example, n is equal to 77 and q is equal to a divided by b, for example, if you have multiple statements, you must put curly braces. When I write Java programs, even if there is only one statement after if, I still put this. So if later on I want to add a new statement, I just open here a new line and add new statement. Okay. So I advise you to use, even if there is only a single statement, I advise you to open curly brace and close curly brace after the if statement. And of course, put an indentation inside the block. When we have a block, this is a block of statements. When there is a block, the statements inside the block are indented by 1 compared to the curly braces. Some people prefer putting open curly brace on the same line. This is my style. I use it like that, but it is perfectly all right if you just put this after the if statement. So repeat, if the Boolean expression is true, A greater than B, for example, then the block is executed. If the condition here, the Boolean expression here is false, it jumps over and continues with the next statement. If this is true, it executes the Boolean statement, the block, and continues with the next anyway. Let's put here something like A equal B multiplied by C. What is A? 12. What is B? 4 and C? 3. 4 times 3 is 12. A is 12. 12 equal to 12 is true. Therefore, these statements will be executed. What is an if-else statement? We can have after the if block. This is called if block. We call this if block. And we can have an else. And then again, curly braces. And we can have here some other statements. N is equal to -1, for example. So if this condition is true, if this Boolean expression is true, the if block is executed and it jumps the else and continues with the statements after the whole if else block. This is the whole if else statement. Okay, this whole everything is here is if else statement. If the condition is false, it jumps to the else, executes the else block, and then continues with the statement after the if else block, if else statement. So either this or that part will be executed if we have if else. If the condition is true, if block is executed, continue with the after the statement after the if else statement. If the condition is false, execute the else part and continue with the next statement. Here we see some examples. If height less or equal to max, blah blah something, and else some other thing. If this if this Boolean expression is true, if the value of height is less than or equal to the value of max, then adjustment will be assigned 0. Otherwise, adjustment will be assigned max minus height, and it will continue with the next statement, whatever comes. Here, since there is only one statement, we didn't put curly braces, but putting curly braces will make it more readable, maybe. Here we have first ch. It looks from here that it's a character variable because we have here a character. Let me remind you that when we have, you probably remember that we have 8 basic data types. One of the basic data types is char. Okay. If I specify a char variable, char h, for example, I can assign a character to h by using single quotation mark and a single character. 8, character 8, for example. Or h is equal to semicolon, for example. Okay. Don't mix. This semicolon ends the statement. This semicolon is a character that is assigned to variable h. So when we want to use a single character, we use just a single quotation mark. In Java, if I want to define a string, how do I define a string? We will see this later on, but I will write it. For example, name equal, then I will put double quotation marks. Okay. A string is defined with the string class. String is not one of the basic data types. There is a string class in Java. Name now is a string object, and it is assigned this string. We cannot write strings with single quotation mark. If you do this, you will get an error. Okay, this is not valid. For defining strings, we have to use double quotation mark, and for using characters, we have to put single quotation mark, but between single quotation marks, there should be only one character. I can have, for example, here \t. \t is a special notation for defining tab character. This is a single character. Okay, this is a tab character. Or \n is the new line character. Now let's go down to the if statements. If else statements. Here we have another example. If count is greater than max count, then do these two statements. Otherwise, if this is false, do the else part, increase the count plus means increment the count. Whatever the value of count was before, it is increased by 1. Is this understood so far? Any questions? This is quite similar to Python if statements. Now, nested if statements. What is a nested if statement? There's an if statement inside another if statement. If statement and another if statement. This if statement is nested inside this one. This kind of if statements inside if statement are called nested if statement. If num1 is less than or equal to num2, then we go to this block. Inside this block, we have another if statement or if else statement. If this is false, if the first expression is false, we go to else, and inside else we have another if statement. There is some special cases for nested if statements. For example, let's int h equal, for example, 12. Assume that I want to have some Java program which handles, let's say, 4 cases for age. If the age is less than, for example, 3, 1 or 2, it's a baby. Okay, so I will have if age less than 3. Let's print, for example, system.out.println baby. If the age is not less than 3, if it is 3 or more, but less than, for example, say 16, then it's a child. Okay, so let's close this. Oh, sorry. So what I will have an else here, and inside this else, let's put this here. Another if statement. I can put here another if statement. If age, now, in order to come to this else part, age less than 3 should be false. Therefore, H cannot be 0 or 1 or 2. It is either 3 or more, okay, in order to come to else. So it is guaranteed that when we come here, H is equal to 3 or more. So if H is less than, for example, 16, less than 16 or 17, up to 16, assume that we want to print something like, I will just put on the same line. Let's copy this, Control C, put it here. Child. And here I have another else. In this else, if I come here to this else, it is certain that H is not less than 3. It is equal to 3 or more. And here I compare less than 17. If it is between 3 and 16, this will be true, and it will print child. When it comes to else, we know that H is not less than 17. It is either equal to 17 or more when we come to else. So here I have something similar to this one. Control C, I will put it here. I will fix this in a few minutes. Okay. Here, if it is, for example, less than 24 up to 23, let's call it young. Otherwise, I want to print, for example, middle-aged. So here I have a sequence of nested ifs. If H is less than 3, do this. Otherwise, go to else. In the else, we have several things, okay? Everything here is inside the else. Let's make this readable, okay? So in this else, from here to here, I have another if statement. If H is less than 17, we do something. Otherwise, we have now else of this if. If H is not less than 17, it is 17 or more, we come here. If it is less than 24, which means that up to 23, 17 to 23, we print young to the screen. If it is not less than 24, which means that it is 24 or more, we print middle-aged, for example, or adult or something like that. So, but I can combine this in a more nicer and more understandable way. What I do, I just remove this. I write here else space if. Okay. Therefore, I remove that. And here, I use this. In order to make it look similar, I will do that. So I don't need this indentation anymore. Now, this is equivalent to the previous one. If H is less than 3, do this. Else, if H less than 17, do that. Else, if H less than 24, do that. And then else, do this. So how does it work? If the first logical expression or Boolean expression is true, the first part is done. It jumps all the else if block, etc., everything, and continues with below. Okay. If this is false, if H less than 3 is false, then it checks the second Boolean expression. If the second Boolean expression is true, it executes the block corresponding to it and then jump down. If the second condition is also false, then the third condition is checked. If the third condition is true, the block related with that one is executed and continues with below. If this is also false, it continues with the else. So here I can have not only 1, 2, 3, but 4, 5, 6, 7, 8, whatever necessary. Okay, I can have this kind of nested if is quite common. If there are several variations for the same value, like age or some other things, then we can have this kind of thing. But you have to be careful. You don't need to put here if age greater or equal to 3, and I can do this, but this is useless, because in order to come to this part, to this else if, this has to be false. So it is already ensured that age is greater or equal to 3, okay? Because in order to come to else, this must be false. Therefore, age cannot be less than 3. It must be either equal to or greater than 3. So this is already guaranteed. So I don't need to write this, okay? Is this understood? And similarly, in order to come and check this Boolean expression, all the Boolean expression in the same nest if statement have to be false. This has to be false. This has to be false, so that it will come to this else statement, and then it will check this condition. Therefore, it is guaranteed that age is not less than 17. Age is equal to or greater than 17. It is guaranteed here that we have something like this. Age is greater or equal to 17 is already guaranteed, of course, and we now compare age with 24. I hope this is clear. So we can have this kind of nested if statements, which checks several cases together. For example, we can have it's comparing strings is let's also okay. Let's have car language equal. For example, I'm using, for example, T for Turkish. I can use E for English, F for French, E for or whatever, D for Dutch. Okay, and Deutschland. So here I can have, for example, language equal, if it is T, say günaydın, print günaydın. If language is English, for example, Control C, let's take this one, put it here. If language is English, print good morning. If the language is, for example, Spanish, what is good morning for Spanish? Buenos días, good morning, good day, else wrong language code, for example, okay, something like that. Or let's put here one more. If language is D, print Guten Morgen, for example. Okay, we can have this kind of comparisons by equality. Okay, the previous example is by ranges of the numerical values, but here we have just comparing the same variable with some specific values. If it is T, print do this. If it is E, print do this, etc. Or it can be, for example, an int. If language code is 1, it is Turkish. Or instead of T, I can have this. If language code is 2, it is English. If language code is 3, it is German. If language code is 4, it is Spanish, for example. Okay, so we can have this kind of nested if statements which compares against specific values, either character or integer or whatever. Okay, is this understood? I hope this is understood. I will stop my lecture now because I have another lecture following this one. I have CS101 lecture just in a few minutes time. Do you have any questions about if statements, nest if statements? Okay. Thursday, I will continue with comparing strings because you cannot use equality or relational operators to compare strings. Strings are compared in a different manner because strings are not basic data types. Strings are objects, and we cannot compare objects using equality or relational operators. The same is valid for strings. We will see how to compare strings in the next lecture. Thank you very much. I will